Lambda functions are a feature in Python that allows the creation of small, anonymous functions. They are defined using the lambda keyword and can take any number of arguments but only have one expression. The syntax is much more concise than that of traditional functions defined using def and is typically used for short-term tasks or as arguments to higher-order functions. Lambda functions do not have a name, hence anonymous, but can be assigned to variables for later use. Example, Python add2 lambda xx plus 2. The syntax for defining a lambda function in Python consists of the keyword lambda, followed by a list of arguments, a colon, and a single expression. The structure is as follows: Python lambda arguments expression. Unlike regular functions, a lambda function does not use the return keyword. It implicitly returns the result of the expression evaluated from its arguments. Multiple arguments can be separated by commas and specified without parentheses. Example, Python multiplies lambda xy, x to y result equals multiply 3, 4, result is 12. Lambda functions are commonly used in various scenarios where short, throwaway functions are required. Here are some typical use cases. 1. Filter data. Use a lambda function with the filter function to filter values in an iterable. 2. Transform data. Use a lambda function with the map function to apply a transformation to each item in an iterable. 3. Sort data. Use a lambda function as a key for sorting lists. 4. Data frame operations in pandas. Use lambda functions with the apply method to manipulate data frames. Example, Python numbers equal 1, 2, 3, 4, 5, 6. Filtering even numbers. Even numbers equals list filter lambda x sent to with 0 numbers, 2, 4, 6. The advantages of lambda functions include 1. Conciseness. They allow for writing functions in a single line, making code cleaner and easier to read for simple tasks. 2. Anonymous functions. They eliminate the need to name functions, which is useful for short-lived functionality. 3. Functional programming. They support functional programming paradigms by being used as parameters to higher-order functions like map, filter, and reduce. 4. Less boilerplate. They reduce boilerplate code for simple operations, enabling faster and simpler coding. Example, Python #hasher, using lambda with map to square numbers, squared equals list, lambda x through 2, 1, 2, 3, 4, 1, 4, 9, 16. Despite their strengths, lambda functions also have limitations. 1. Single expression. They can only comprise a single expression, limiting their functionality compared to full functions. 2. Debugging difficulty. Tracebacks may be less informative because lambda functions do not have names, making debugging harder. 3. No type annotations. Lambda functions can't have type annotations, which can impact readability and usability in larger codebases. 4. Readability issues. Excessive use of lambda functions can lead to cryptic code that is hard to read and understand. Example, Python, this will cause confusion due to lack of clarity. Complex equals lambda x plus lambda y 5, not easily understandable. Examples of lambda functions can illustrate their use and structure. 1. Simple addition. Python addition equals lambda a plus b result equals addition 2, 3. Result is 5. 2. Sorting with custom key. Python fruits equals apple, banana, cherry. Sorted fruits equals sorted fruits, key lambda x, sorts by length of names. 3. Event handling in GUI. Python button equals button root text equals click me. Command equals lambda print button clicked. Common mistakes made with lambda functions include 1. Using statements instead of expressions. Trying to include multi-line code or statements leads to syntax error. 2. Confusing free variables. Not understanding how free variables are captured can lead to unexpected behavior. 3. Not naming lambda functions properly. For reusability and clarity, always consider assigning to a variable if the lambda isn't a one-off request. 4. Reading difficulty. Writing complex lambda expressions that are difficult to read and understand. Example, Python incorrectly attempting to include a statement. This will raise a syntax error. Bad lambda equals lambda x, print x. Lambda functions are a powerful feature in Python that enables developers to write concise, anonymous functions for short-term tasks. They are best used for small, simple operations that would benefit from their syntactic brevity. While they provide many advantages, such as enhancing functional programming capabilities and reducing boilerplate code, They also impose limitations with respect to function complexity and readability. Knowing when and how to use Lambda functions is key to effectively leveraging their power in Python programming. In summary, Lambda functions are not a replacement for full functions, but serve as a useful tool in specific contexts, particularly when paired with other high-order functions. Be mindful of their limitations and strive for clarity in your code. Example of summarizing usage. Python sum lambda args sum args. Result equals sum lambda 1, 2, 3, 4. Result is 10.